Hey guys, welcome to another video. So today we continue on with the nice question series. Today's question comes from the Extension 2 syllabus from North Sydney Boys. Now, this question, when you look at it, it's hard to get started. So I thought I'd give it a go. It's 4 marks near the end of the paper, so generally considered to be quite hard. So now, before I go on, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends. So let's start. North Sydney Boys 2023. Now, this question looks quite simplistic. It's 4 marks, and generally when that happens, it's hard, right? Because there's no sort of direction for this. So let's have a read. So it looks like it's a regular octagon with side of 4. I mean, that's quite important. So let's give it a highlight. So we have these points here making up a regular octagon. So we know the size of the angles. That's important. Now, A is the midpoint. Okay, cool. Find the value of, looks like the magnitude of the sum of all those vectors. Okay, now, diagrammatically, right, A1, so basically it's like that vector, right, there, this one, this one, this one, this one, this one, this one. So the sum of all these vectors, magnitude, that's what I want, right, the size of that. So now, there's a couple of ways to skin this cat. So I'm going to show you the vectors way first, right? And maybe I'll dabble in the complex way of doing this, complex numbers way of doing this. So now, to do this, I mean, it doesn't really need you to sort of have a rotated octagon. So what I'm going to do, I've prepared one earlier, just like a good cooking show, right? Prepare an octagon that actually has it sort of nicely aligned. So the vectors way that I'm going to show you is this, right? So right now, in this diagram, I have point A over here, right, and point P1 over here, and point P8 over here, right? Yeah, so if I define, let's say I define, maybe I'll draw it all the way down, an axis, right? Let's say that's the y-axis, and let's say I start the x-axis over here, right? So let's say this is y and this is x, right? And I'm going to find expressions for the vectors relative to point A, right? So relative to point A. So, and not only that, I'm going to be smart about it, right? So what do I know? I know that first vector there and the last vector there. I'm going to do it in pairs, right? So for example, if I said to you P1, so A P1 as a vector plus A P8 as a vector, right? Now, what does that equal to? So in terms of A being the origin and P, now I know what the distance is, right? Because the whole length is 4, so that must be 2 and 2, right? So then in terms of vectors, right, that's like minus 2i, right? That's AP1, and then plus 2i. So these two add to 0, right? First pair, that's the sum. Now, let's consider the next pair, right? So this one over here, so this is P2, and this one over here, that's P7, right? Now we just connect it with a line there. So I want the sum of those two, because you can sort of see what I'm doing. If I find the sum of the 4 pairs, which make up the 8 that I want, I'm then going to add it through, right? And then hopefully that gives me something that I can find the magnitude of, right? Let's see. Now, to do this, it's really easy if you sort of visualize this. So AP2 plus AP7. Now, I need a vector expression for these two. Now, this is what I want you to see. Can you see, whenever I add a vector to the left and to the right that's symmetrical, the x values will cancel out, just like above, right? How the x values cancel out, gave you 0, right? So theoretically speaking, if I add this guy with this guy, the x will cancel out. And what do I get? I get 2 times the y value, right? Because I get y value over this side and the y value this side. And so the way that I'm going to see it is, and maybe I'll define it as, I'll just define this coordinate here as, I don't know, let's call that B, right? So in this case, this guy just equals to 2 times the vector of AB. Yeah, then it's just up to me right now to find the expression of AB, right? So AB. So I'm just going to draw as a pink vector there, right? Now, AB is just the height of this, right? Because I know, right, that the height so the length of this guy here is 2. I can use Pythagoras, right? I can use Pythagoras, and I know, guys, right? If I sort of took a triangle here, in fact, you know what? I'll draw the triangle here, right? Right? And I'll sort of take it off. Oh, maybe I'll leave it there. So I know that this side, sorry, it's not 2, it's 4, right? The side is 4. Now, you know that for an octagon, if you use that sum of interior angles, blah, 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 you'll get 135. This is 90, so this must be 45 degrees, right? And this must be 45 as well. Yep, which gives me, by Pythagoras, right? So, if I had to say this is x over here, right? I can go sine 45 equals to x on 4. That's like root 2 on 2 equals to x on 4. And then x equals to 2 root 2, right? So that height there is 2 root 2, which makes the vector AB equal to 2 times 2 root 2j, right? Or negative, right? Because I'm going downwards. Does that make sense? So the vector AB this is like the origin over here, right? Would be, if the height of that distance is 2 root 2, then it'll be negative 2 root 2j. Does that make sense? So then that gives me negative 4 root 2j as an expression. Right? Perfect. Got my second, my second pair, right? Let's keep going. Now, if I go down to the third pair now, right? So this one over here to P3, this one over here to P6, right? Same thing, draw yourself line there, AP3 plus AP6, right? Once again, now I need a vector that goes, let's call this coordinate here, C, goes down to C. C, you can sort of see that this guy here plus this guy here gives me AC, right? I already found the green highlight part. That's 2 root 2, right? And I know that this side here is 4, but then 2 root 2 plus 4 is going to be my y value downwards, right? So I know that this is going to be 2 times AC, which is 2 times minus 2 root 2, minus 2 root 2 plus, also minus another 2, minus another 4 actually, right? J, right? Does that make sense? So let me say that again. Minus 2 root 2 is this bit. 4 is this bit. And as a vector, then it'll be minus 2 root 2 minus another 4j. Now, why is it multiplied by 2? Because when I add these two vectors together, the x values cancel out, and you sort of get like 2 times the y values, right? Yeah, cool. So guys, once I get that expression now, you can expand that a little to make it, yeah, let's expand that. So that becomes negative 4 root 2 minus 8j. Okay, and I have one more pair to do, right? One more pair to do before I add them all up and then find the magnitude, right? So the last pair for this guy there, that's P4. This guy here, yeah, that's P5, right? So then I go AP4 plus AP5 equals to, now let's give this D, let's make that D, right? So I need to find the vector that goes all the way down to D, right? And I'll 2 times it because the x value cancels out, right? And so 2 times the y values. And guys, we know that if I was to add, this is 2 root 2, this is 4, whoops, this is 4, and this is 2 root 2 as well, right? Because it's the same sort of height, right? Because it's a regular octagon. So then I know it's going to be 2 times minus 2 root 2 minus 4 minus another 2 root 2 j, right? Yeah. And cleaning that right up, let's see what we get. So we'll get negative now 2 root 2, that's minus 4, so minus 8 root 2. And then minus another 8 j. Right, once we have, zoom out once, and once we have these 4 pairs, right, we add them. Yeah, we add them, which basically means I add that, 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 and that to get therefore, right? A1, so can I just write it like this, right? Let's just be lazy. Let's go sum of A, P, I. I'll go when I equals 1 to 8, right? Just lazy, right? You can you write the string out, but I'm just lazy. That's the same thing. Yeah. Now that equals 2, the sum of all these 4. So let's add them through. So minus 4 root 2, minus 4 root 2, minus 8 root 2, that's minus 16 root 2, minus 8 minus 8, so minus 16. Yeah. That is the sum of all vectors. And then, guys, the question wants me to take the magnitude of this. If you take the magnitude of this, right? If you take the magnitude of that, because there's no x value, it is literally just the guy in front. So magnitude of that just becomes 16. Now let's factorize it. Root 2 plus 1 units. That's it. So this question is quite nice. If it's a regular octagon, right, we're just going to do it in pairs, right, and slowly come down, right, till you get the 4 pairs. Sum it all up, which means you sum up all those green vectors there. And when you do that, take the magnitude. Because it only has y, a y direction, the magnitude of that guy, don't need to do Pythagoras or anything. It's just whatever that scalar is in front, which is 16, factorize root 2 plus 1. How's that? Yeah. Now, guys, if you wanted to explore this question using, maybe I'll do it as well, right? Maybe I'll do it. Yeah, I'm seeing a bit of time. You can do this by using complex numbers, right? And using roots of unity to help you. So maybe, you know what I'll do? I'll copy the question and I'll just skin it in a different way, right? Let me just delete all these highlights. Yep. All right. So another way to explore this, if you wanted to go down this route, right, is to, once again, right, this is A, this is P1, and this is P8, right? Let O be the origin, right? Be the origin. So then I know the distance between, so there's a vector here, OA, right? And obviously there's a vector here. So we're going to use complex numbers and vectors to some extent, right? There. Now, if I told you from the origin, if I drew all the lines going to all the corners, right? Can you sort of see, this is like the solution you can get when you have complex roots of unity, right? 8 roots of unity, in fact, right? So basically, I can say if this is origin, I can sort of try to define, right? Z equals 2. Now, normally when it's complex roots of unity, what the number here is, it's basically the radius of this guy, right? So what I'm after now, I want to find the radius of one of these signs, right? So to do that, pretty straightforward-ish, maybe. We're going to use some trigonometry and some SOHCAHTOA, right? So SOHCAHTOA, so trigonometry with some double angles, and I'll show you how. So if we just zoom in to one triangle, right? One triangle. Now, we know for this one triangle, right? This side is 2. Now, what's the angle here? These lines here, can you see bisect the angle, right? And I know the angle is 135 degrees. So half of that would be 67, right? 67.5. So this guy here, maybe I'll draw it a bit bigger. Just to illustrate the point. I'll do it over here, actually. Right? Oops. Right. So picture this side to be AP10, right? So this triangle here sort of zoomed in, right? Now, so I know this length is 2. This angle here, which is half of 135, is 67.5 degrees, right? And the side that I really want is OP, right? So therefore, if I said, let's let it be X, is that what I want? No, let me see. Actually, do I want that? You know what? Before I do that, can I find the length of this guy first? Right, and I'll get OP later, right? But for now, let's deal with OA first, because I need that. I actually need that side for later. So, yeah, I'll show you why. 67.5 equals to X over 2. Yeah. So then now, 67.5, guys, I can't really find that as an exact value really until I go, well, now, I know that tan, if I sort of let this guy here be theta, then tan 135, which is 2 theta, equals to 2 times tan theta all over 1 minus tan theta, right? Just be clear, this is theta, and this is theta, right? So now, what am I trying to get to? So I'm going to sub in. Now, I know that tan 135 is going to be what? That's -1, right? That's in the second quadrant. 2 times, if I sub in x minus 2 on top, so 2 times x minus 2, sorry, x on 2, over 1 minus x on 2. I just want to make x a subject, right? So what do I have here? I'm going to times this up, so it becomes like -1 minus x on 2 equals to, oh, sorry, it's squared, isn't it? Yeah, squared, sorry. So 1 minus this guy squared equals to x, right? Maybe I'll throw the negative on the other side and expand 1 minus x squared, so plus x squared on 4 minus x times it all by 4. I get a quadratic of, wait a second, something's wrong. 1 minus, is this right? 1 minus, no, I've got my signs wrong. Give me a sec. Sorry, that should be squared, right? 1 minus t squared, 2, okay. 10, that's -1, negative there. 2 times x on 2, 1 minus that, okay, cool. 1 times that times 2 is that, plus that. Huh. Why does my, give me 1 second. Just want to figure out the algebra here. So 2 times tan of this guy, which is x on 2, 1 minus this guy squared, right? Okay. Now, if I get that, okay. Okay. What? And then 1 minus this up here, the minus x. Oh, I expanded a perfect square for some reason. Sorry, that was very silly of me. Yeah, I mean, you guys probably already screaming at me. And you get that? Yeah. So then times everything by 4, so that becomes x squared minus 4x, and then minus 4, 0. Is that right? Yeah. Feels right. So let's see, if I completed the square, chuck the 4 over, add 4, becomes 8, is it? And x equals to plus minus 2 root 2 plus 2. I think that's right, actually. Perfect. Now, it's plus minus, guys. This is a length, so I'm just going to take the positive only 2 root 2 plus 2. Now, so x is that, which makes the magnitude of OA that. Cool. Now, I'm now then going to use OP. I won't find OP yet, right? Oops, sorry, I won't find OP yet. Right, so basically OP1, OPI, yeah. So let's go, this guy equals to magnitude of OPI, yeah, like that. Yeah, that's my eighth root. So just to be clear, what am I trying to do? So if I let this guy be the radius, right, which is what roots of unity does, now I'm going to try to solve this, right? So check this out. Yeah, so where you can sort of say where OPI, yeah, where I equals to 1 all the way to 8 are the roots of unity. Now, if they're the roots of unity, in this case, right, we know that the sum of the roots, maybe I'll write the sum of roots. Don't be lazy. Sum of roots should equal 0, right? Because you can sort of see that they all cancel out, right? Sum of the roots equals 0. Yeah, by that I mean like this guy cancels out with this guy cancels out with this guy, etc., right? Because these roots are uni. Sum of the roots are 0, right? And in fact, if you use polynomials, right, it should be 0 because there's no Z7 coefficient. So therefore, the sum of all roots, right? Sum of all the roots of OP, right? Because they're the roots, right? Equals 0. Yeah. Now, I know that from a vector's perspective, OP is the same as, yeah. Therefore, sum of OP is the same as sum of OA plus, put in brackets, AP equals 0. Now, this is why I need to find X, right? So just to be clear, what was X? X is OA, right? So this guy here, this is OA. Yeah. I'm going to sub that in now, right? So I'm going to put this guy into here, right? So when I say sum, I mean like from I equal to 1 all the way to 8, right? So sum of I equal to 1, 8 of this guy, 1, 8. So this is a constant, and it equals to 2 root 2 plus 2 plus 8 p. Oh, sorry, I should put a little I there, right? Yeah, I equals 0. Yeah. API. See, yep, API. It's not even API, is it? Because they're all the same. So let's see. P1. Oh no, it's API. Yeah. API. Yep, perfect. Now, guys, take a step back. What do I want, right? Yeah, the question says they want you to actually take the sum of AP, right? APIs, right? So they actually want this bit. Sum of, that's the question, right? And then I take the magnitude. So this is what I'm going to do. Because it's a constant, right? Because this green bit here is a constant, I'm going to throw that over the fence, right? Yeah. So there's eight lots of those over the fence. So then I go, therefore, sigma I equals to 1 AP I equals to 8 lots of this, but with a negative, right? So negative 8 times 2 root 2 plus 2. And then the last piece, right? They want me to basically magnitude this guy. And that's my answer. Because if I magnitude this guy, now this is what the question wants, right? And then this guy here equals the magnitude is, if I just expand that, if I factorize the 2 actually, of 16 root 2, oops, sorry, 16 root 2 plus 1, which is the same answer as I got before, yeah? So this one here, a bit more complicated. I like the vectors solution better, but this one here, just in case you need to do it with a little bit of complex numbers, set your roots of unity where the center is the origin. Find the value of the height of OA, which is the green highlight there. That's constant, right? Because then using a bit of vector sum here to here. So OP, this guy here is the same as that guy plus that guy, right? Sub in the green and then make the pink the subject and then magnitude it and you'll get the answer. Guys, I thought that was a pretty cool question. 4 marks, North Sydney boys, pretty hard question. Hope you liked it. If you haven't already done so, please subscribe to the channel, like the video, and tell your friends. Thank you very much. See you at the next one.